This video is brought to you by the volunteers of the Santa Fe Alliance for Science. In a previous video, we learned about the Fibonacci numbers. In this video, I will make the connection between the Fibonacci numbers and the golden ratio. Remember, Fibonacci lived about 800 years ago in the city of Pisa in Italy. Pisa, of course, is known for the Leaning Tower, which was almost finished when he lived, but not quite. The Fibonacci number series is this one: 1, 1, 2, 3, 5, 8, where each of the numbers is the sum of the previous two. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8. And we also saw that you can find these numbers in nature, in the grocery store and out on the street. This is about ratios. What is a ratio? A ratio is simply one thing divided by another. For example, if I have 12 apples and 4 children, the ratio of how many apples per child is 3. There are 3 apples per child because 12 divided by 4 is 3. So it's just one thing divided by another. So here is the Fibonacci series again. So now let's take the ratio between adjacent pairs of Fibonacci numbers. Adjacent means side by side. It is best to use a calculator for this. So the first one is 1 divided by 1 equals 1. The second pair, 2 divided by 1 equals 2. The third pair, 3 divided by 2, is 1.5. 5 divided by 3 is 1 2/3. 8 divided by 5, etc., etc. So what do you think the next numbers are? You can stop the video here, you can pause it, and see how far you can go. Next, we're going to graph these ratios. So for this you would need graph paper or paper with lines on it, or a ruler or something that allows you to make graphs. We'll make the graph as follows. We have on the vertical axis, we have the ratio here, and on the horizontal axis you can recognize the Fibonacci numbers. So the first ratio was 1 divided by 1, and you see we put a dot here, equals 1, 1 here. This is the ratio. The next one is 2 divided by 1. 2 divided by 1 is 2. We put a dot at the 2. The third one is 3 divided by 2 is 1.5. We put a dot at 1.5. 5 divided by 3, 1.6. 8 divided by 5, etc. Now what you can see is that in the beginning these numbers sort of flop around and then they settle to a value that is 1.61803, etc., etc. This number, this is the one that is called the golden ratio, this number 1.618. So why is this ratio so interesting? One of the reasons is that about 2,000, 3,000 years ago, the Greeks and the Romans used this ratio to design some of their buildings. They believed that this ratio led to the most pleasing shapes. So for example, the width of this temple divided by the height of this temple is equal to the golden ratio, 1.6. And there are other ratios in here that refer to the golden ratio. Now let's do an activity. Let's get out a ruler, a meter stick, a tape measure or something, and we'll go measure ratios of things we can find around the house. Again, keep your calculator around. So here here we have something that you can do at home too. I have a bunch of things here and we're going to measure the ratios. I have a newspaper, I have a worksheet, I have some magazines, some books, the calculator itself. So let's go do it. First, let's do the newspaper. 31, so newspaper, Santa Fe, New Mexican. Let's do the height first, and then the width, and then the ratio. So the height is 56 centimeters. The width is 31 centimeters. And the ratio is 56 divided by 31. 56. 31 divide 1.8. 1.8. I'll write down 1.81. Let's see what else we have. Let's grab a magazine here. This one. Make magazine is 24. So make 24 high by, and we can go around and do lots of things, including the calculator. Let's do the calculator. 13 by 8. So 13 divided by 8 is 1.62. 1.62. Calculator. And we can go around the house and measure up all kinds of things. The table, the door, I'll do the front door, a window, a placemat, the top of the recycling bin, all kinds of things. So you go out, get your tape measure out or your ruler and go measure up these things and write them down, and we'll make a graph of it in the next one. So here are some of the numbers I collected, and of course you can make your own collection with things you found around the house. So remember, the newspaper was 56 high by 31 wide. The ratio is 181, and I'll make a graph here on the right hand side that shows the ratio. That is, this is 1, and then 1.5 and 2. And I made a dotted line where the golden ratio is 1.6 and a little bit. So here goes. Newspaper is 1.81. I'm going to plot these ratios. 1.81 is right here. The Make magazine, 1.41. It was a little less. 1.41 right here. The New Scientist, 1.35, a little less than that. The Pasatiempo, 1.18. Ooh, much lower, right here. The Bill Bryson book, 1.54. 1.54. See, 1.5 is here, and 1.54 is very close to 1.6, the golden ratio. The book called Europa, 1.5. The calculator, 1.62. Well, what do you know? The door is 2.19. So the door, my front door in my house is there. I have a window, 1.16. Ooh, quite low. Here. And the recycling bin was 1.26. 1.26 right here. Now let's look at these things. Most of the ratios of these rectangles that we saw fall on the left-hand side of the golden ratio. A few of them fall on the right-hand side. So notice that the right-hand side, where the ratio is like 1.8 or 2, that is where things are tall and skinny. The door, the newspaper. On the left-hand side are things that are more squat, more fat than the golden ratio. Most books, the magazine, and the only one that falls really on the golden ratio is the calculator. Okay, I'll leave you with a riddle. Do you think you can find anything in your house that has a ratio less than 1? Here's one extra tidbit. In the world of mathematics, some numbers get used so often that they get their own name. For example, you know this one, 3.14. It's got a name, it's called pi. It's the Greek letter for p. So our number, 1.618, etc. It also has a name. It's called phi. It's the Greek letter phi, which is the Greek letter for F. Pi was the Greek letter for P. There are two more I'm going to mention. One is 2, and I'm not going to explain what they are. 7, 1, 8, etc. He's got a lower letter E, and the strangest one of them all is the square root of -1. He's got the name little I. So that's for the math nerds. That's it. I hope you learned something. There'll be a third video about how Mr. Fibonacci brought the number 0 to Europe. See you then.